Hello everyone, thank you for showing interest in my presentation about solid principles and how they help to create one of the most popular PHP framework, Symfony. My name is Vlad, I work as a technical architect in WebNet France. I am certified Symfony developer, and recently I started to contribute to its code base. So, at the very beginning I will speak a little bit about Symfony framework, its features. Then I recall you what solid is and why you should care. Then we consider each principle separately on the example of Symfony Components and to see how it was beneficial to implement this principle. Symfony framework is both a set of reusable components and a PHP framework for your web projects. The main aim of your Symfony application is to convert HTTP request to HTTP response. For this, all requests arrive at the unique place, which is called front controller. It's a single script. Then this script initializes Symfony to determine a controller to execute. Controller, it is your code, your business logic for generation HTTP response. We don't put all the logic of generation HTTP response to controller. We separate business logic in controller, data persistence in model, and response generation in view. This is a converting of template to a valid response in HTML or JSON and any other format, which is a well-known MVC pattern. Symfony components aim to resolve their specific task, which we encounter usually when developing web applications. There are a lot of components in Symfony, nearly 50. These components are highly decoupled. Being the basis of full stack framework, they can be used separately in any project and even as an essential part of another frameworks. The main of them are HTTP Foundation, routing, event dispatcher, HTTP kernel, dependency injection, and others. Additional functionality is organized into bundles. They provide controllers, roles, assets, JS files, templates, and so on. The most important one is framework bundle that glues all components together in a full-fledged framework. Then Symfony recommends to use, but doesn't force, another third-party libraries, for example, Doctrine to communicate with database, and Tweak, which is a template engine and template language. Then you add your code to get a complete application. Solid principles. Solid is an acronym which each letter of which represents an important principle of developing object-oriented code. Solid helps to design systems that is reusable, flexible, maintainable, and understandable, and to avoid such unpleasant things as fragility of program, duplication of code, viscosity, and unreasonable complex of your programs. Single responsibility principle advises that a module, a class, or component must have a responsibility over a single part of your application, and this responsibility should be entirely encapsulated in your class. Consider the example of report service. This service can create, search, filter, and export reports. Even though this class works with single entity, which is a report, it depends on heterogeneous services. For example, creating of report requires some manager or mailer, etc. Searching and filtering works exclusively with database, which is another service, and exporting may use a file system or some specialized library as PDF. The better approach would be to break this class into three others: report manager, report exporter, and report repository. Let's take an example of e-commerce site with these common features. We want to store users in database with orders, and we want to allow users to log in to our application and to allow users to create orders. And automatically we would like to associate the currently authenticated user with an order it creates. For this, we can use services provided by Symfony. Service is just a useful class that helps us to achieve some goal. All services are managed by service container. This class is a centralized place for service creation. When one service depends on another service, this dependency gets injected in the constructor of the first service automatically by container. This is called dependency injection. So, in Symfony, we can use security context service, which stores the token of currently authenticated user, its username, email, roles, etc., and user object. And this class can manage authorization thanks to isGranted method. This authorization sometimes needs reloading user from database, and security context uses authorization provider and user provider to retrieve this user. At the bottom line, entity manager, which manages all entities in your application in the database, like user object, like order object, it will retrieve all the users from database. While doing this entity manager dispatches a lot of events. And when we are about to create an order and store it into the database, we can add our order listener that will intercept this event and provide the order with an object of authenticated user. For this, order listener depends on security context. And the order listener will be automatically created by service container to be passed to entity manager. At the same time, this order listener requires security context, which brings us to circular dependency. This is because security context does a lot of things. What was really done in Symfony at some point is a separation of security context service into two distinct services, which allowed us to dramatically reduce the risk of circular dependency when working with authorization and authentication classes. Open-closed principle is about leaving entities open for extension but closed for modifications. That means that you should be able to add or modify the behavior of entities without touching their source code. There is a lot of techniques to stay in compliance with this principle, like abstraction, inheritance, polymorphism, dependency injection, and a lot of design patterns. As I mentioned, all requests arrive at the same place. This is a front controller of Symfony. It initializes kernel object of Symfony and the request and passes the request to the handle function. This handle function is defined in HTTP kernel of Symfony, which is very open for extension, because this handle function of every step of request handling dispatches a lot of events, allowing any listener to influence this process. So where do these listeners come from? Merely from anywhere. Usually they are registered in bundles that you define in your application under kernel, under app namespace. This is your class that you create. So this is a handle function. At the very beginning, when request arrives, the request event is dispatched. It allows listeners to add additional information to request object, like language of user or locale of user. Also, another listener can provide a response at the very beginning of request handling, like authorization listeners can block the access to the user and return 403 HTTP response, or redirect user to login form. It can be it can have enough information at this step to stop handling. Then, when controller is defined and controller, this is your code, your business logic, before it gets executed, a controller event is dispatched, allowing, for example, to change the controller. Then we need to define the arguments of this controller. The arguments of your controller can be request object, any service from service container, or any parameter if your URL is parameterized. Controller arguments event is thrown immediately, allowing you to change or to add parameters. Then your controller gets executed, and handle function see if it returned a response object. If it's not, it's give a chance to any other listener to convert what controller returned to a valid HTTP response. Usually there is a template listener that defines a template and converts it to HTTP response in the form of HTML, JSON, everything. After that, a response event is thrown, and any listener can modify this response. After that, before response is sent to client, finish request is dispatched, and after that, terminate event is dispatched. At any time, an exception can arise. For example, when no controller is found for a given URL. In this case, an exception event is dispatched, and there is a listener that can transform this exception into a beautiful response with a, I'm sorry, there is an error in a site, so try later. Then, Liska substitution principle argues that objects can be replaceable with any of their subtypes, which is a simple polymorphism, but with an important clarification. Your program must remain correct. And the correctness of your program is compromised when wrong class hierarchy or wrong abstraction are chosen. Therefore, LSP describes rather semantic inheritance than purely syntactic. This principle is better described on the example of its violation. Fortunately, there was no such mistakes made in Symfony, so I will show you how to avoid problems related to LSP when developing Symfony applications. Here is a classical example of violation LSP. Geometry tells us that a square is a regular rectangle with an additional property, the equality of heights and widths. So we define rectangle with height and width, with setters of these fields, and a method to get an area. In Square, we enforce this property of equality. And there is no surprise that any client that works with rectangle will fail when we pass square object on its place. Let's find out why this happens. LSP suggests a behavioral condition which resembles those by design by contract approach. That means that you can straighten precondition in your subclasses, that you cannot weaken past condition in subtypes, and invariance must be preserved in any child of your class. Consider set width of a rectangle class. In a precondition is that width is an integer greater than 0. Post condition is that width is a new width, and invariant is that height remains unchanged. Now we understand that this invariant is not preserved in square class because we added a new invariant, the equality of width and height. So let's find out how to avoid such pitfalls when developing your Symfony applications. In Symfony, there is a central point where you can check authorization of currently authenticated user, authorization checker class. Authorization is based on token, that is the information about current user, username, email, roles, etc., and user object. Then the attributes. This is the privileges you want to ensure the current user possess, and the object, which is an optional object. For example, you can check if user possess role admin, if user can edit comment or view or manage order. So any code which has access to authorization checker can check user privileges. Authorization checker uses token storage to get access to user object, and provides is granted method to check user rights, which delegates the decision, the final decision, to Access Decision Manager. Access Decision Manager contains lots of voters. When it is asked to verify privileges, it asks all voters for this decision and makes a final decision based on these votes. It is easy to add your voter to this array with a custom authorization logic. But there is an important post condition that vote method of voter interface must return one of these constants, granted, abstain, or denied. It's not simply true or false. If you return true or false, your entire authorization layer would be compromised. So you must respect this past condition. Another example. Doctrine is an PHP libraries that provide a way to communicate with database because Symfony doesn't provide a component to work with database. It tightly integrates Doctrine. Doctrine is an ORM, which is object relational mapping. Here's an example of this mapping. Imagine that you have classes like article with ID, author, date of creation, and text, and author with an ID, name, and array of articles. The function of Doctrine as ORM is to store automatically this object in the tables of your database. Each line of database corresponds to an object in your PHP. When we ask Doctrine to return us an article with ID 17, it will automatically search and extract information about this article from database and to provide us with an object ready to manipulate. During this process, Doctrine dispatches a lot of events like pre-persist, post-persist, pre-update, post-update, etc. Here's an example of article entity. It contains two listeners like pre-persist and pre-update to automatically update date of creation and the date of update of this article. The precondition here is that event is usually article. It's 100%, you can be sure that this is article, this is no problem. If we would like to initialize the fields created by and updated by with an object of currently authenticated user, we cannot do this from inside article because this is a simple plain PHP class. It has no access to services, to service container to get the currently authenticated user. So we must, in this case, create a separate listener which has access to currently authenticated user. But the precondition of these listeners are different. Because these listeners are invoked when these events happen to any of the entities, we must explicitly verify the type of the entities. Interface segregation principles advises that client-specific interfaces are better than one general-purpose interface, because no client should depend on method it doesn't use. Consider the dependency injection component of Symfony. In your application, there are a lot of useful classes, useful objects that are services, like mailer helps you to send emails, entity manager helps you to persist data in database, etc. So there is a central point of creation of services, which is called service container. To get a service container to know about services, there's a little bit of configuration in the form of YAML, XML, PHP. For each service, you define ID, class name, and its dependencies. This information gathered from different places are assembled together, compiled, and the service container is ready to use. So from the point of view of its clients, service container must provide a way to get services via get method and to verify if service exists via has method. This functionality is so common that there is a container interface defined by PSR. A PSR it's a standard recommendations that many clients depend on. Then other clients of container must have a way to provide it with its services. Like extensions in your applications must have a way to add their services to container. So they use another service, container interface, from dependency injection package. Finally, container implements all these interfaces, and it is used directly by kernel class. So depending on the client, we must use one of these interface and nothing other. Another example. Here is an example of a single route in your application. It helps Symfony to define a controller to execute when a new request arrives. Usually you defined a route name, route regular expression pattern, and between curly brackets, you define the parameters, which can take any value. Within the constraints, when the value isn't provided, default value is used. Many roads are grouped into a collection of roads. This collection is used for both URL generation and URL matching. URL matcher uses this collection to define the road and parameters from the arriving request object. While in your code, you would likely to generate links. So for the given road name and parameters, URL generator will return you a path. It can be relative, absolute, or whole URL. Since this functionality of URL generation and URL matching is closely related and based on the same collection, one single router class addresses this functionality, but it implements distinct interfaces in order that clients of router depend only on the functionality they need. Your code is likely to use URL generation, while Symfony uses URL matching when it needs to define a controller for the incoming request. So interface aggregation principle remains simple when you think of the clients of your classes. Dependency inversion principle is a way to decouple high-level models and low-level ones. It suggests reverse this traditional dependency of high-level components on low-level ones. But instead of simply reversing this dependency, it suggests adding a separate package of abstractions, which high-level models will use and low-level models will implement. So imagine we have a high-level model kernel in the framework package, and it uses logger from monologue package to log arbitrary messages. In this case, kernel is coupled with a concrete implementation of logger, monologue. It is simply to reverse this dependency by forcing logger of the monologue package to implement logger interface in framework package. But this can be done if you are developer of both these packages. If you are not, there is still a possibility to use a bridge pattern. So a more flexible solution that this principle promotes is to add a new package of abstractions. Abstract logger framework kernel will use it, and monologue logger will implement it. What was actually done in reality with a PSR logger interface. It is a standard released by authority in PHP land, and they suggest to use it when you need to log something, and to implement when you want to provide a library that logs something. So this situation is omnipresent in all Symfony code. For example, when a Symfony form package, which handles the need to show and submit in user forms with the input data, if it wants to validate this input, it can use Symfony validator package. But instead of directly dependency on validator object, it depends on validator interface. One of these implementation is validator object. But nothing prevents you from using another validator. You can write even one by yourself. In this case, Symfony validator interface plays a role of a package of abstractions. And that's it. Thank you for your attention.